Here is grade 7, module 8, lesson 2. I can write two-step inequalities for real-world scenarios, and I can determine whether given values are solutions. So just a reminder, a solution of an inequality is any value of the variable that makes the inequality true. Okay, so we have Max here who wants to rent a bicycle. The cost to rent a bike is $5 is a $5 insurance fee plus $3 per hour. Max has at most $20 to spend. Write an inequality to represent this scenario. Could Max rent the bicycle for 4 hours? So we're going to have two different parts to this. We first need to figure out what our equation is, and then you're able to plug in 4 for X to see if he can rent it for 4 hours. So we're first going to start by writing an expression to represent the rental fee. So we know that this rental fee is $3 per hour. Okay, $3 per hour, or 3x. Next, we need to figure out what that insurance fee is. Now, the insurance fee is just once. It's a one-time charge. So that's going to be $5. Okay, and then we're going to add them together and set the sum as less than or equal to the amount of money Max has to spend. So we're going to write our inequality here, adding them together. And now we need to solve for X. We got to simplify as much as we can. So first we're going to, actually, you know what? We can just plug in for our X. Yeah, let's plug in 4 for X and see what we get. Does it make a true statement? 3 times 4 is 12, plus 5 is 17, less than 20. Yeah, 17 is less than 20. So he will have enough to rent his bicycle, or rent the bicycle, for 4 hours. So there are answers that we were looking for. We needed to write in an inequality. So we didn't need to solve it. So this, if it was asked to solve it, we would have needed to get this to X is less than a number. But it just said to write it, which works out because then we're able to substitute in for X the number of hours that he wants to rent the bike. And if it makes a true statement, which it does, then it is possible. If it would have made something like 22 is less than 20, a false statement, then it would not have been possible. He could not have rented the bike for the 4 hours. So because he can, Max could rent a bike for 4 hours. All right, we have a taxi charges a flat rate of $2.25 plus an additional 50 cents per mile. Annie has at most $10 to spend on the cab ride. Could Annie travel 18 miles? So let's start by writing our equation. So we have our 50 cents per mile. So that's going to be our X, 50 cents per mile, plus our flat rate. Okay, so here's our flat rate. Here's our flat rate. Our cost per mile is here. And then at most, she could spend $10. It isn't or equal to, because at the very most, she has that $10 bill. So really imagine that. She has a $10 bill, not $9.99. $10. So that is an or equal to. So when we have our inequality like this, we can plug in what we know here. So we're trying to see if 18 miles works. So we're going to plug that in for our x. So 0.5 times 18 plus 2.25 is greater than or equal to 10. Pause the video. Simplify this. These are like terms. You first need to do a little multiplying and then add your 2.25. Pause the video and see, what do you think? Is that possible? Not possible? All right, so 0.5 times 18 is 9, plus our 2.25 will give us 11 and 25 cents. Is that less than or equal to 10? Nope, that is false. So, no, she could not travel 18 miles. It looks like these are close, almost 18 miles, but not the 18 miles she's looking for. So no, she could not travel 18 miles.